Hey, folks. I don't know if I'm a master at anything except cutting gigantic cakes. All right, let's figure out how to share screen in this. How's everyone's day going? Good? Not good? All right. Okay, so what we're going to do today is I figured we go into some testing and some of the new improvements we've made in testing around 4.3, and then kind of go into using the dependency injection container, look at how that works, how that integrates into testing, and then finish off with some browser automation. So I've recently been working on some side projects and in my day work, and browser automation has been really helpful. And just so happens that it's actually not too rough to do anymore. That's my microphone. Okay, my microphone might be the wrong microphone. One sec. Behind Ring Central. No, the microphone should be the right microphone. I can try and talk louder. Okay. Yeah, I don't know how to make it more loud. Lima Charlie. I don't know what that means. Okay, I'm going to keep going and hope that people can hear me. Yeah, okay. All right, so we're going to write some tests. I don't know if I'm going to show it. I can't show it for very long. We're going to write some tests. And so a lot of what we're going to be looking at is in a terminal. So I have a bunch of terminals here, but we're just going to look at this one and this one. We can run PHP unit just to make sure it all kind of still runs. So we've got some tests that we inherited from Jorge, and we're going to add some more tests. So the first thing we've done, or the first thing I'm going to do is write this database migration to add two tables. So we have a users table and a calendar items table. Because in the example I'm going to walk through is going to be going through. Okay, it's going to be going through kind of fetching some calendar items or pretending to fetch them, and then syncing them into a database. And so we'll kind of go with these two tables. And normally, if we're going to write tests, we'd also have to generate fixtures, but that sounds embedded. These ones here. My internet connection is unstable. Wonderful. So these kind of static fixtures with the schema in them, I don't much like them because every time you make a schema change, you have to then remember to go back and also update the fixture schema here. And it becomes really like arduous and annoying. So I'm just going to delete all of this. And yeah, I guess those are users. And what we're going to do instead is we're going to upgrade this app to 4.3 and then start going from there because that'll be more useful. So we're going to use DevMaster. You should never do this in a real application that pays your bills or is otherwise it is important to anyone other than you because it's not a good idea. So we're just going to smash in some dev libraries. These will all get stable releases eventually. But right now they're all just dev branches. And so we're just going to replace everything with dev branches. I'm just going to pick some version numbers. We're going to do, yeah, we're going to do some dev versions. We're going to update with Composer. And then from there, we're going to make some more changes. So I mentioned that there's a new fixture system in 4.3. And so we have to update PHP unit's kind of integration with Cake so that we can use that new fixture system. All right, so the next thing we have to go into and change is our PHP unit configuration. So historically, Cake has used a PHP unit listener to connect into PHP unit, and that interface is being deprecated. And so what we need to do instead is use the new extension system that PHP unit offers. So we're just going to type some XML extensions. This is the point where you all learn that I suck at typing. That's okay. Actually, we got there. Okay. Let's see, fixture. So we're going to swap in this new extension. And that extension is going to attach into PHP unit and then also let us kind of track fixtures being added and removed. And then the next step is to kind of start our schema off. And so in previous versions of Cake, you would put your schema directly into your fixtures. And what we've kind of replaced it with coming in the new release is a more flexible system that kind of lets you use the migrations that you're already using. So I saw some messages in chat earlier about people using various migrations tools. If you're managing databases, you should most certainly use migrations. If there's more than one of you working, or if you have more than one environment, so if you're not just live coding on the production server, strongly recommend using some sort of schema management tool. And so I've got this application set up to use the Cake migrations. Of course, you could replace the system with migrator. It's hard to talk and type. You could put in an extension point for kind of anything. So what this will do is run migrations if they need to, if necessary. And what it'll basically do is when this line gets hit, it'll go into your application's migrations directory and then run all your migrations against your test database. The benefit of that is you no longer need to manage the schema in migrations and then also manage the schema in your test fixtures. You just need to manage schema in your migrations. And so we can kind of see that. We're going to run PHP unit again, and it should all run. There's some errors, can't describe groups. Yeah, because we kind of blew up the database, right? That makes sense. So let's just go to that test case, and we're just going to delete that test case for now. This is how you get tests to pass. Just delete them. Where is that test case? Am I on the right file? What's going on? Oh, this is table tests. Reading. Okay, so I'm just going to delete all of this stuff. There, tests all pass. That's how you make test pass. No, don't do that. I'm just joking. So what we're going to do now is we're going to generate a controller. And then we're going to generate some tests for that controller. So we're going to generate a user's controller. We already have a user's controller. Yeah, so we've got a user's controller. So we're going to make a new test for our user's controller. Okay, big test controller. So we baked a test for our user's controller. User's controller. Okay, so we have a test there, and then we're going to bake a controller that we're going to add in for, we'll need it in a little bit. We're going to call it calendar items. And that'll make a controller and a test case, which is good. And then we can actually, write some, go to this user's test. So we can kind of, we've got our users, we've got groups, we're going to delete groups. So our users fixture is good. So we'll put in, my first name, Mark. Yeah, good password. All stars on your screen, right? Anyways, so we've got no schema in our fixtures. We do have the fixture being loaded, and then we're just going to delete all these tests because we're just going to write one quick one, kind of look at the fixtures. So we're just going to do this: get users. Query let's insert response. Response okay. Is 200. And then we'll get the users and this. You can just dump that out. Make sure that there's one user present, because there should be one user, because there's one user in our fixtures. Ooh, users.username. What's going on? So my migration has a different schema for users. That's fun. So we're going to go username. So one thing that the static fixtures won't get around is needing to have your schema in sync with the rest of your schema. So there we go. So now we have this one fixture record being inserted, but the schema is managed by our migration. And if we look at our database, I'm using SQLite just because it works really well for demos. There should be a tests database somewhere in here. And I don't see it, but we have SQLite 3. We can just do schema. And there are our tables. So we have a users table. We can do like this. There's our users table, and then we have our calendar items. Right. And if we never have to get out of SQLite. Okay, so we're going to delete that database. And then we'll just add another table to this migration. So just call this one cakes. We'll call this, I don't know, flavor. This is mostly just to show you that if we were to add more tables, and it would generate our tables for us. And we go back into acceptance. Database is it using? Most interesting. Okay. All right, now time to look at our configuration. I thought I had this set up correctly, but let's see what database we're using. Let's use a tests.sqlite. Where? Okay, we're going to keep going. So the tests are still running, so the database is going somewhere. I'm not able to find it right this second. And we can even dump out the users to make sure that it's the right one. And there we go, Mark's running secret. Okay, so that's kind of the new fixture system. One of the other things that the new fixture system can let you do is you can have tables tests run within a transaction. So currently, at the beginning of each test, we clear the database. So we truncate all of the tables that are referenced by fixtures, and then we insert fixture rows. Then you run your test, and then at the end of the test, we truncate the tables. Another approach that is now available as of Cake 3 or Cake 4.3 is the ability to run tests within a transaction. So at the beginning of the test, a transaction is opened, the test runs, the transaction is opened, fixtures are inserted, the test runs, and then the transaction is rolled back at the end. And what this lets you do is never actually persist data to the database. So no data actually gets written to the database. It all just kind of like goes into transaction and then gets deleted. And this is pretty useful for applications that don't need to change schema. and for applications that dynamically create their fixtures. So one of the caveats that truncating tables has when you use them for fixtures is that your IDs don't stay consistent, because when a database transaction is rolled back, the sequences and kind of serial keys that you've used, they get incremented forward, and you can't ever get them to go back. So the question is, what if the project's code already uses transactions? Yeah, you can still use the transaction flow for fixtures, but what's going to happen is as your application goes into transactions, it's going to create save points. And then the save points, when you commit, if you manually call commit, the save point's going to go, it's going to go up and down through the save point stack. How efficient are fixtures when your system has 500 tables? I would not use static fixtures for 500 tables. One of the nice things that you'll get with the new fixture system is that schema won't be created and destroyed at the beginning of every test. And so you can kind of see that if we go into the test bootstrap. So what's going to happen is the beginning of each test, it's not actually going to run migrations every single time. Just look at the code for this. It'll only create migration. It'll only apply migrations if migrations need to be run. And the way it figures that out is by looking at the state of the Finks log. So if the Finks log is the same as the current migration, then tables migrations will not be run. If the head of the migration tree is different, it'll truncate truncate all the tables in the, drop all the tables in the database and start over. From the history of the migration, run all of your migrations at the beginning of your tests. So that's one benefit of the new kind of schema management in tests, is that it'll only apply migrations if they need to be run. If they don't need to be run, migrations are not run. As for managing fixtures for 500 tables, I would avoid static fixtures because what you're going to end up doing is inserting a ton of rows on every single test, and most tests are not going to use all 500 tables, right? Instead, what they're probably going to do is like maybe interact with 10 or 15 tables. So instead, what I would do is just have the fixtures loaded for that specific scenario. And I would also lean rows in those fixtures because you don't always need the same rows. And a lot of times what we've seen with people with static fixtures is they end up they have like different fixtures for different scenarios. And what I found useful in my work is to either have a bunch of factory methods that create records, which we can get into, or to use a plugin that connects with Faker, which we'll walk through as well. So kind of one potential path for this is we'll go into our fixture, and we're just going to kind of comment out those records. So now there's no records in our test fixture, so we just have an empty record. It's going to fail because there's no users. But what we can do is we can make a method here. Let's call it. We're going to call it make user. And they get a username and a password. I'm going to default everyone's password to secret. And what we're going to do here is I'm just going to use a table registry. Autocomplete is sucking. We're going to get the users table. And we'll make a user. And we'll make a new entity. Username, and then the password. Cannot type today. And we'll do users say user. Right, so here we can we'll do save or fail, just so that it's a test, so it should fail in spectacular fashion. So here we could, before we do our get, we can call this, make user. Another thing to do if you're using this approach is to always return the object at the end. Because then you can do interesting things like if you had something that needed the user. What is going on? I'm trying to go to the beginning of the line. Okay. So now we can make a user. It needs a username, so we'll just call this one Mark. Have this one called, I don't know, IMAD. Right, so now our test should fail again because we're going to have 2 users. Okay, that's neat. What is going on? Users like username. So definitely different users. What's going on? Okay, so there's no users. If we make 1, there's 2. Validation failing. Ah, interesting. So when we updated the schema, we did not update the user entity. So the mass assignment rules of the ORM are stopping us. So we're just going to change that to username. We're going to change that to password. In fact, a bunch of you at home already figured that out. There we go. So now the test should fail in a different way. Or not, because there we go. So that's another way you can approach dynamic fixtures, is to create all of these maps, one for each of your methods, and you can refactor this out into a trait or into a base test case class and use it that way. This way it works. It has no dependencies, which is nice. It's just very straightforward, very simple code. But over time, it may become more challenging to maintain. One of the other things that this doesn't really do is it makes it a little bit tedious to generate lots of data. So another kind of solution for that is to use kind of fixture factories, which is a plugin from the folks at Beards Noir. And what that kind of does, let's take a look at that. So just drop that in there, and we'll compose her up. And so it depends on Faker, which gives you some tools to generate fixtures really quickly, which is nice. And so it also generates some new bake commands, which we can look at. I thought it did. Yeah, it does. Where is it? Oh, we didn't load the plugin yet. Go to application. And we'll find where debug kit is. We're going to add in, I think it's called fixture factories. Just looking up in my cheat sheets. What is it called? There was a plugin that needed to be loaded. Let's take a look. It's in the README. Save the README. So composer require, there it is. Bootstrap CLI. And we'll load in the fixture factories. So now when we run bake, there should be, there it is, bake fixture factory. So we can do bin cake bake fixture factory. Look at what options it has. So it allows you to generate a fixture factory for a specific model. And so we'll do one for our users model. Fixture with a table suffix. Interesting. The reason this is coming up is because we don't actually have a database for our application. So I'm going to skip over that, and we're going to get one I made earlier. User factory. Grab one I generated earlier, just in case these types of things happen. And factory. Type in factory. Okay. And then we'll make a new factory, anything called user factory. And so the user factory here allows us to have the user, like the root registry name, which is kind of like what model it goes to. You have to require dev TSX 4.3 to validate. How to write efficient test scenario for model validation. Okay, yeah, we can get into that, Eric. 1 sec. We can do that with, I don't know if we have a lot of validation. Use the same test, yeah, data source for test and default. I should do that. Or hey, you're right. So getting to the root of like what fixture factories let you do is they let you define like a default template for your records. So when you want to generate a bunch of records, you can kind of ask Faker to give you like random emails or random passwords. So this gets you like pseudo random data to put in your database, you can use inside of your test scenarios. And one of the benefits of this is that you don't have to have all the static fixtures kind of set up. You can also define different sets of like different pre-baked sets, so different scenarios inside of fixture factories. So you can have a new accounts setup. You could have like a very large account kind of scenario. And so you can have those baked in sets of scenarios ahead of time. You can bake them all into your fixture factories and then be able to use them over and over again across your various test suites. So this kind of helps manage the maintenance cost of test data over time. And say you add a new column, you can just go and update your default templates. And then that new column is in all of your test suites, all of your test cases automatically. So yeah, that's a good strategy to kind of get towards dynamic fixtures, and also helps with maintaining fixtures long term, and also allows you to work towards having those transaction-based tests, because they can run quite a bit faster depending on the number of tables that are involved, the number of like operations you're doing. So yeah, if you're not changing schema and you are working, trying to figure out a way out of kind of the static fixture mess that your application might be in, I would suggest looking at fixture factories, and if you can't, make the big jump to it all right away, using the factory methods that we kind of just covered is another approach. Okay, so then you want to talk about validation for models. And so the way I would approach model validation, if you have really complex validation rules, what I kind of end up doing is, oh, sorry, we didn't actually use the fixture factory to make our fixture. Jumping ahead. Okay, so instead of this make user, what we're going to do is we're going to call user is going to be user factory, and it's I think make. I think it's even make. I always forget how to do this. Make, we're going to make one record and we're going to persist it. Persist. And then we'll get a user. And if we run our test again, it should pass because we're going to get a user. Right. And if we run it a couple times, we'll see that user. So this time its name is Carolyn Lynn. If we run it again, we'll get the same person, which is weird. But what if we make 2? Then our test should fail again, and we should get 2 users. So we've got 1 user, and we've got a second user. So that's kind of how you can get into generating multiple records. Yeah, because the fake of this, yeah, the seed starts off in the same place each time. Right. Makes sense. All right. So that's kind of a very like brief overview of like how you can approach fixtures in a way that isn't just like typing in gigantic arrays and having them, you know, kind of cause pain for you longer term. So the first thing is, again, like moving the schema management into moving it into the migrations and reusing your existing migrations that you're already using to also manage the schema for your tests. And the second kind of dimension on that is making all of your test scenario data as dynamically on demand. So you only create exactly the data you need, so that you're not truncating hundreds of records across, you know, dozens of tables. And as say you had like, you know, maybe 5 or 6 factories you need to coordinate, you could always move that into a protected method as well, so that your tests don't have a lot of repeated setup code at the beginning of each test. So that's kind of a strategy I've been using. Found it super helpful for getting things to work the way they do. This is also really helpful if you have chains. The fixture factories kind of take care of chains of records, which is kind of nice. So say we were going to make another factory for calendar items. So I mentioned before that we we're going to kind of play around with calendar items. So we'll make another fixture factory for that. And I'll just get my pre-made thing because I've not taken the time to set up the database properly. So here we have, again, calendar items is the name of the table. We're kind of generating a record here, and then we're using a user here. So what we could do is do user ID, right? And then we could use another factory to make our user. So we could get a user from here, and we could do, user factory make 1. We're going to persist it because I'm being lazy. And then we're going to use the use clause. We're going to do a users controller test. Calendar items. So this. We're going to make sure we get 1 user. So now we're going to make a calendar item, and we use calendar factory. We're going to make 1 of those. We're going to persist it. And my editor has lost the plot. There we go. This might not work because I have not created a calendar item model, or it will work. That's cool. And so we've ended up with 2 users. Interesting. And we need to add cannot find picture app calendar items. Yeah, that makes sense. Let's just run migrations. Okay, migrations, migrate. and then it'll just make the SQLite database, which is nice. I don't know where it put it though. Where is it putting the SQLite databases? This is both the joy and curse of SQLite. Where did it put the files? And where did they go? So it should be making them here. Let's just make sure this is commented out. No SQLite files. Most curious. Most curious indeed. Bootstrap. Let's see what's going on here. Where should the databases be? Oh yeah, that would do it. Slashes. Slashes are hard. Slashes are hard. So root doesn't contain slashes, which makes it a fun one. Okay, so now we have that app SQLite. Did it make the database this time? Still no databases. It's still not putting them in the right place because we didn't rate the file. And there we go. Okay. So, okay, so now we have cakes, we have users, we have calendar items, exactly what we were expecting to have earlier. And stop quit to get rid of SQLite. Okay. Oh, we got that now. So now we can do bin cake, bake, fixture, and we can make one for calendar items. Okay, so now we've got a calendar items fixture, and delete this record because yuck. Delete all of this stuff. Yeah, so if you've moved off of kind of static data fixtures, you end up with these like empty fixture classes. They seem kind of redundant, but what they do let the framework know is like which tables you're expecting to be truncated. We haven't quite gotten a good solution around that. There are, some community solutions around using triggers to track which tables have, changes applied to them. Yeah, you can explore those solutions if these like empty fixture classes kind of bother you. I don't see them being too annoying because there's not really a lot of maintenance to be done here. And I kind of like how explicit the fixtures list at the top of the test is, because it makes it very straightforward to know like what pieces of the database this test is going to modify. But if that's not your jam, there are community solutions for doing this in a different way. And run that test again, and there we go. So we've got 2 users again, which is curious. Where's the second user coming from? This is some new stuff that just landed very recently. So the locator aware trait used to have to do get table locator and then get the table you actually want. And now what you can actually do is just use test index makes 2 users. I cannot follow chat and Q&A and think and type. It is not that good. Line 50. Yeah, but these users should be deleted at the end of the request, at the end of that test method. Okay, so now we have 0 users. Interesting. I'm probably operating the fixture factories class incorrectly. That is my current guess. Is that I'm just holding it wrong. Anyways, I don't want to belabor this too much, but you can get there. So you can have the calendar kind of create a user. As we can see inside here, there is a user. That's the user. We want to debug. Yeah. What's going on? Okay. So this does have a user ID. That user does exist in the database. You can probably look at the database. But it's going to be all truncated at the end of the test. So there'll be nothing but C. That makes sense. Okay. The way you can make, if I could spend the time to figure this out, this is kind of going off script. Anyways, going back to that question about model validation. So if we went and we're just going to generate a test for a model. That's for model users. Model is not a valid choice. Of course not. Okay, so validation. The way I would approach validation is building entities that don't pass your validation, and then just passing them through and having a test for each scenario that you have. So we'll put in a username of 50 and save user. Connect fail. We'll try groups. I did write the file. Okay, so our validation rules are first name has to be set, last name has to be set, email, password. So we'll just change this around. Username. We don't want to allow an empty string. So we want it. We need username on create. We'll cap out usernames at 250, and we want usernames to not be an empty string. It's kind of implied by the max length. Not at all. Okay, and we don't need active. Okay. I'm gonna have to restart them in a minute. It's having a day. Yeah, users.password is not there. It's interesting it saved it. That seems wrong. I know why. We forgot to add a mid-length. Patch the entity. Oh, yes, you're right, Hatman. Good save. Good save. I would know this, right? True. And so then you kind of just write scenarios for each of your validation sets and each kind of validation rule you want. I would not do validation testing at the controller level. What I usually end up doing is I write validation scenarios for all of the models. So you have, all the validation rules are there, and all the, scenarios you're concerned about, like registration and updating, and all of those all have, validation set scenarios. And then I also write like one test for the controller to make sure that validation is connected. And that validation messages are, displayed in the right place, or displayed in a Flask message, or output in the right place in the JSON response. And that just kind of gives you, like, you have the lower level test of, running through all of the validation at the model level. And then you also have, like, is the validation output connected in a way that the user can see it? So that's kind of what I like to do. The other school of thought is like do unit tests for everything. I don't entirely like doing that. I kind of prefer more of a functional test. So that having that one functional test that ensures validation is set up is a good one. Another approach is to do all of your validation permutation testing at the controller level with like controller. That's a very valid approach as well. I kind of like it as well because it lets you ensure that the whole application works. But you do end up running a lot more of the controller code because you're looping through the controller just to test validation scenarios. So if I had to do if I was really concerned about validation in an application, I would probably do like tests like this where you're testing the specific validation scenarios. Yeah. Let's put my notes back up. Okay, so next is the DI container. So we can imagine that we have like a service in our application. And what that service is going to be, it's going to connect to some remote thing. And the way I like to think of services in a Cake application, there's no service directory that comes in the skeleton app because we kind of want you to paint outside of the lines for your application, kind of like for services, because there is no real, like, we can't give you anything that makes services easier to build other than a DI container, which is what we included in 4.2, and I'll kind of walk through a little bit of how to use that today. So there is no service directory built in the application. There's also no like bake tools for services because again, like there's not really a lot the framework can do for that. So what I end up doing is I usually end up calling them like calendar service. I'm just going to get one I built a little bit earlier. We can kind of talk through that code quickly instead of watching me type very slowly. So in the service, I'm going to just a basic class, just a regular PHP object. We're going to use the locator aware trait because we want to talk to the ORM. We're going to store a reference to an HTTP client and one of our ORM records. We're going to take that client as a dependency. This allows us to either mock it or replace the client over time, and just avoids like having constructor logic inside of our services. So, and then there's like, it can do a couple different things. One is it can talk to Google Calendar API, You can imagine that this would return something. This actually isn't a calendar API, so it's just calendar list, right? So if we were to talk to Google, it could talk to Google. We could kind of protect the application from that external dependency. And that's kind of where I see services fitting into a Cake app, is like when you need to wrap up logic that is coordinating between a remote service, or you want to coordinate logic that goes between multiple ORM records, or you have like a more complex save scenario, you could put all that into the relevant controller method. But over time, you're probably going to need it again. And your kind of options are like, copy and paste, or have the controllers inherit from each other, which is kind of awkward. And so what I find I prefer to do is to just take that kind of like application logic, that coordinating logic, and put it into a service. And then if that service has, additional dependencies, you can add it to the DI container. Even if it doesn't, you can still put it into the DI container. We can talk about some of the benefits that has as well. So now let's wire up that DI container. The other thing we have here is we have like a get local, which is, imagine we're syncing calendars locally. So there's like a remote list, and there's a local list that we've kind of cloned locally. And we don't want the application to really know like where each of those are. And so, yeah, we wrap it all up in a service. This is just very much intended as like an illustration of like how you can have a service kind of talk to a remote API or multiple storage engines, or maybe the storage engine changes over time. Like maybe this client isn't just a remote service. Like maybe it's like, I don't know, Bigtable or MongoDB or some other storage that you don't want the application to have to interact with on a low level. And service classes are a great way to kind of do that. So then we go to our DI container, right that. And so container services are defined in your application. And so we have this like services hook that you can define methods in, and it gets a container. And so the container has a few methods. It has an add, which lets you define a service. It has extend, which lets you like augment an existing service and give it additional parameters. You can get a service, which will construct you an instance and give it to you. If that's a shared instance, you'll get the shared version of it. If it's not a shared instance, you get a new instance every time you call get. And then has will let you check if a key is there. So that lets you build like control flow logic around like what's in the container and what's not in the container. And then lastly, there's this add service provider, which we'll get into in a little bit. So what we're doing is we're going to add the HTTP client. We're just going to make sure it's the right one. Do class, and the client has no constructor dependencies, so we're just not going to do that. Then we're going to add another service, which is the calendar service. And then we're going to add an argument. So you kind of have to define what all your constructor dependencies are in the container. This has, does add some repetition because you do need to wire everything together externally. The container also has like an auto discovery mode. I don't personally use it very much. It can be useful if you just don't want to have to type everything out. I lean more towards like being a little bit more explicit, and I prefer just typing out all of the constructor dependencies. Just lets me makes the code easier to understand in the long term, and a little bit more maintainable over time. Okay, so we've defined two services. You can imagine this service list is going to get really, 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 really long and be really obnoxious to read. And so what the container also lets you do is have service containers, not service containers. Brain is not working. It allows you to have service providers. So you can do container, and you can add a service provider. And we'll call this new like calendar service. Calendar service provider. Doesn't exist yet, but we're going to make it. Right, and we're just going to delete all of that. And then we'll go in here, we'll do calendar provider. We'll make a new class. Calendar and service provider. And it's like a public. I'm not going to remember what the functions are. What is it called? Check real quick. Back off camera. It's called services because we wanted to keep them all the same. That makes sense. And then inside your service provider, you can define the same services. So we can add the services, and then we also need to tell the service container what it contains. So one of the things that having all your services defined in the application class does is they will all that setup logic gets run on every request. Whether you use those services or not, all of that setup logic gets run. But what a service container lets you do, or service provider lets you do, is connect just the things that are necessary. And so we can just get this set up real quick. So what we're doing here is we're saying that this service provider provides the following classes. So if you need to fetch a calendar service or an HTTP client, you can do it from this service provider. And so when the container is asked, can I have an instance of calendar service, the container will go through its direct services and say, I don't have that service, but then it'll delegate to the container, the service providers, and ask which of you service providers can provide me with a calendar service. And our service provider would, I can give you one of those. And at that point, the services method would be called. And then all of those services would be added to the container, and then the container can find the right service. So this allows you to defer the definition of services until you need them, which can be a big help in a larger application. Going back to that like 500 table application, there's probably many services hiding in that code. You don't need to start them up all the time, so we can kind of do it like this. So now we've kind of wrapped it, and our application is kind of straightforward and easy to read and easy to kind of maintain over time. I kind of scale up as the application gets bigger. And then we don't also have like 500 imports inside of our application class as well, which is another nice little kind of code cleanliness type thing. Okay, so now we want to use this calendar service provider. So we're going to bake like a quick. Did we bake that? Okay, so we baked this calendar items controller. And so what we're going to do here is we're going to just tell this that we want a calendar service. We're going to call it calendars. Right, so now we've told the controller we'd really like a collection of calendars, like a service of calendars. And so we're going to get like our remote calendars. We're just going to call service and get calendar list. Controller calendar service, yes, that's right. It's not as a class name. Everything is good. Go back to these calendars. Okay, then we can set this as a view variable. Okay. And then we just need a quick little view template for this. And then we'll add an index, PHP, up there. here, we'll echo JSON code. There are better ways to do this. I'm doing this just as an illustration. Okay, so now what will happen is when our controller method is run, Cake will find the calendar the calendar service, create an instance of it, inject it into the controller method, and so we'll have it right there. Now we don't have any like additional constructor logic. We don't have any extra setup, which is kind of nice. It's just you tell the framework what you want, and the framework will give you what you need. And I guess one other thing that's probably interesting or useful to note is if you have route parameters, the services will be injected in the right spots. So you could kind of interleave this with your route parameters. Please don't do that. It's just going to make your life rotten. So like, say you had a page as one here, a page parameter. You know, you could put the page first, but please don't. The style I would recommend you do is like put your services first and then put your past routing parameters at the end. Another interesting addition to 4.3 is that if you type the route parameters, the router will cast them for you. So you'll actually get an integer, or you can get a float, or you can get a Boolean. The framework will automatically convert 1 and 0 into Booleans. It'll convert integers into integers. It'll convert floats into floats. And one nice thing with the integer cast is that if you get a float value, so if it was like the page was 1.543, the framework will actually raise an error on that and say like 1.543 is not an integer, like you can't call this controller action. We can do that with tests as well. So we're just gonna skip this for now, and we will come back to that. Make sure we have a test for this. We're in the wrong place. Controller, calendar items controller. All right, so we need calendar items, and we need app.users, right? And then we're not gonna make anything. We're just gonna call calendars, and this will fail. That's okay. What we want to do is to okay, right? That's what we want. And we want, a variable calendars, and we want this to be not empty. That's what we want. That's what should happen. That is not what's going to happen. When we run this, it's going to fail epically. And the reason it's going to fail is because we have not, connected our Google API to anything. It's also going to fail because we messed up the service provider. There we go. What does this mean? Calendar service provider is not compatible with services missing dot comment. Core container interface found void. Yeah, but I fixed it. The computers are happier now? Nope. Service provider services void. Okay, 500. That's a bummer. Let's see what that 500 is. And so one of the ways you can do that is this disable error. One of my favorite pieces of the test framework is this, turning off the errors so that we can turn it off. Calendar service provider was not found. Neat. That's because we got the namespace wrong. Always important. There we go. This controller calendar is not found. All right, we're getting closer. Calendar controller class for calendar items could not be found. Right there. Controller calendar items. Missing controller exception. Oh, calendars items. Okay. Missing template, calendar items. Index. We named that calendar. Yeah, we did. Okay. There we go. The array is not empty. And we can make sure our calendar service is being called. We can debug the response here. We're probably getting an error from Google. They don't like it when you just bash their APIs with stuff that's you're not supposed to do. Okay, so we got a redirect out of Google telling us to go to the other calendar list. So let's just copy that. And now we are getting an error. Another redirect. Just redirects all the way down. Okay, the redirects does not matter that much. Redirects don't matter. The point is that we're not getting what we want. And we're also talking to Google at this point, which is another problem. Ideally, your tests don't reach out to the external world and kind of hit resources that you're not controlling, right? Ideally, we'd want to insulate this from the internet, because the internet is not reliable all the time when you need it to be. You know, Google could have a problem. A variety of things could go wrong, and so the framework provides like a couple different ways of kind of insulating yourself from that. And let's take a look at one of those. Let's go back to where I was before. Facebook could be down. Yeah, that was a Facebook could be down. That was quite the event. It's happened. And you don't need your CI to fail because some other service is broken. Okay, so we have two ways that we can kind of stub out this this network request. And we'll go through both and kind of the trade-offs they have. So the first way is we could mock the service, right? So we could, you know, with the service mock. So we could mock the service out and tell it that we're going to do something. So let's do that. So we can do mock service. We can call calendar service. Did it import? There we go. Class. So when we want a calendar service, what we're going to do is give it a new constructor, and we're going to give it a new thing that it can call instead. It's not a model M. It's very clacky though. It's the only keyword I have right now. So what we're going to do instead is we're going to use PHP unit to make a mock. Mock builder. Since we've all been stuck at home, I got a really clacky keyboard because there's no one around to complain that it's too clacky. So yeah, that's what I've been doing. Just been rocking a really loud keyboard for a while. At least I can have loud clacky keys all by myself. Right, and so we can configure you know, a typical traditional PHP unit mock. Method get calendar, right? We're gonna just tell it to return a value. it's going to be a list of like ID is 9, right? 9. And then there'll probably be more data in this, but like not that important for this scenario. So you could imagine this response body is coming out from reading from a fixture file, or it could be some sample responses you've captured from this third-party service you're working with. Since we're working on this like example of Google Calendar, maybe you've captured some Google Calendar responses. You want to use those as your test scenarios. This allows you to get into like what happens if Google is down. This lets you test what happens if the authentication token you're using has expired. Lets you get into a lot of interesting test scenarios that are hard to reach without using mocks. Like if you were to test against Google, you can only test if Google's down when Google is down. But through mocks and through like fixture responses, which we'll get into in a second, we can simulate a lot more and be prepared for when those things are broken, and kind of keep our application running as best it can when it's completely trash. So one of the key things when you mock a service with mock service is that you return the mock at the end. Now, it's worth saying that this mock service method does not have to actually use a PHP unit mock. If you have like a dummy implementation, you could totally use that. If you had a null object pattern, you could use that null object here and replace that mock with that other object. I'm just using a mock here because it was straightforward to do. So now we can go back and assert that this, this is not empty, and if we don't need to be, but if we've done it right, we'll get a test that passes, which is kind of fun. And if we dump out the calendars, we can see that's the exact data we put in. So what we've managed to do is in our test case, we've defined a mock. We've injected it into the container. The container, we made a request to the application. The application got a calendar service, just as it's always expecting, except that calendar service, we swapped it out with a fake calendar service that we just made up in the test case. And so that gives us a lot of power on like replacing our domain logic, isolating our tests. You could imagine like, what if you wanted to test all the emails, right? Like you could inject an email, something that records emails into the container and then get like the mail delivery service for your application, and just stub it out and record things. So there's a lot of flexibility that you can do through this container pattern approach. So that's flexible to like any kind of service that you've defined in your container. The next kind of test setup we can do is with a response mock, like a network mock. And this is kind of drawn from some other projects that exist outside of PHP. And so we have to use some stuff here. We need to use a new trait called HTTP client trait. This is a new trait that got added in 4.3, and what it lets you do is stub out HTTP client requests at the network level through some trickery. And we'll get into what that trickery is right now. Come on, redraw with colors. There we go. But first, we're going to make a response, and we're going to make a response using create this new client response. That's what the name was. Kind of threw around a couple of different ideas, so I didn't fully remember what the response was. And the first thing is, so if we look at the signature for this, it takes a status code, and then it takes an array of headers, and then it takes the body as a string. And if you're using JSON, you could read the JSON out of a file again. There's a bunch of ways you could get that response payload. So our headers, we're just not going to provide any headers because we don't really need them. And then for our body, we're just going to give some JSON. If you were building a proper application, like in a real application, you'd probably read from a JSON fixture file or some other way of like getting reproducible, reusable data. Because much like database fixtures, this stuff gets kind of messy over time. What does the BS key on my keyboard do? I have two BS keys on my keyboard. They're both backspace because that's how good I am at typing. I have two backspace keyboards, two backspace keys. Yep, that's how I roll. Just so bad at typing, I just give up. Client get And so we have a bunch of new methods. We have client get, we have client, we have mocks. We can mock, any of the traditional commonly used PHP methods, HTTP methods. So we can mock get, we can mock post, we can mock put, we can mock patch or delete. Yeah, so we can mock all of those. And if we just look at we change that URL. Okay, let's just copy that URL. That's a lot of typing. Okay, so we're going to mock this endpoint, and we're going to throw in this response, right? And then we're going to call calendar items, and then we're going to make sure that all this other stuff works. So here what we're doing is we're creating a new HTTP response, which quacks just like any other HTTP response you would get out of the client. And then we're going to tell it like, hey, HTTP client, when you get a request to this URL, when you get a request to this URL, return this response, right? Fairly straightforward. And so when we run it, we get 2 tests that pass. And if we debug the calendars, we should get 2 of them. Yeah, 1 and 10, which is exactly what we put in here. Yes, that is a picture of my keyboard. Thanks, Michael. Yes, it has 2 backspace keys because the keycap set came with 2 backspace keys, and I didn't. And then I was like, well, I might as well lean into that. Can't type anyways. So yeah, so that's another way you can do mocks. This pattern, I prefer this pattern, mainly because it lets you only mock the things that you can't control. I've had countless problems in applications over time because the mocks said one thing and the actual code was something totally different. So like the mocks, yeah, everything's fine. Like that method still exists, but the actual code, the method was removed or the method was changed in a significant way. And yeah, your test still passed, but your code is broken. I actually had a fun production incident like earlier this year where the mocks added methods back in the application, which was hilarious, but tests all passed. But when we deployed it, it caught instantly on fire and caused everything to break. Yeah, yeah. So yeah, I like this path because this will still have the full service code will all still be running. And so the only thing that's really different, if we look at this, the only thing that's really mocked out in this network request path is nothing. All of the code that we wrote for our application all still runs. And what Cake is doing is when that mock client get is called, this client get, the first thing it does is step into sending the request. It prepares a request. And then the next step is, are there any mocks defined? Have any mock responses been defined? If there are, then it tries to match those against the request that's going to be sent. And if the request that is going to be sent matches, it returns that mock. If the request doesn't match, it actually will raise an error. So we could just add, let's add a second request in here. Let's get crazy. Some new person joined, or we made a mistake, or we typed API, as one does, when you can't type. And so we didn't get a successful response anymore. We got this, we didn't get a mock. So we get an actual useful, we get a useful response out of a useful error code out of the mock client system. So it's telling us it was unable to find a mock response for get, and it gives us the URL we even typed in. And so what this lets us do is ensure that all of the network requests that our application is making either have mocks defined or, yeah, so they don't talk to the external internet because we're not expecting that. We're using mock responses. So yeah, that's kind of a nice little feature. It helps you get to the point where like you're only mocking the code that you don't control versus mocking the code you do control, which helps you get like greater certainty on the entirety of your application working up to the network boundaries as much as you can, right? So those are two ways that I like to use mocks, and to use the service container as well. So you can mock at the service, you can mock at the network request. Two good options for going forward. Another thing that has come up that people have asked in the past is like, oh, how do I define a logger with external configuration? And so you can define loggers in, or like, cache configuration. How do you configure all of that with the DI container? Like, I want to be able to do all that with the DI container. But generally in Cake, we don't really do that because, the global kind of proxies give you enough of insulation from the world. They kind of less about like they operate less on like a dependency injection and more on, they're more like small self-contained service location. But if you do need to define dependency injection for a logger, we can call this one a container logger. And from there we can kind of return container. I'm going to make this a file logger get, and we're going to make a file log. But before we do that, we need to add the container into the closure. User, my goodness. And so we're going to add. We're going to add file log. And then we're going to add an argument to it. And that argument is going to be our configuration array. So you could imagine we read this configuration array from somewhere else in the DI container. We can also use the little magic, what's it called? We called it, what did we call it? Just need to go look at the cake source. Is it container config or config? What is it called? I'll put it in. Nope. Maybe I never built it. Maybe I just thought of building it and then didn't build it. Service config. That, yes. I'm mad with the save again. I'm mad with the save. Thank you, Adnan. All the new stuff in 4.3 hasn't been burned into my brain because I haven't used it enough. So what we can do here is we can then, get an instance of it. So actually, this is kind of dumb. This class, what did I just do? There we go. Okay, so this class is useful if you want to inject. I can will things into existence in 4.3. It just takes time. So this service config allows you to have service classes that depend on configuration. That's its primary use case. So if our calendar service needed to access configure data and we didn't want to like just siphon it out of the global namespace, we could use the service config and get it from there. But what I was thinking about and what I want to do are different things now. And so we're going to just go back to what I was trying to do. And so we can talk about service config in a minute if folks are interested. Just post in chat if you want to see what service config is all about. Container log.log, best name ever. And we need to import log. Lots of people can do it. You can send pull requests. We can all do pull requests. All right, so now we've got a log set up. We've set up our container log, and then we're going to go into our calendar service, and we're going to throw some logging in here. We're going to use my favorite. I like these traits. You don't have to use them, but I use them. Log. Takes a message. Hi, CakeFest. Just put info in here. Good enough. It's not an error. Okay, so now if we run our tests again, we still get that error. What's going on with that? Cannot configure. Oh, so we run into a fun problem. I knew that was going to happen because I prepared. So what's happening is we're overwriting the log config. So one of the tricks with setting some of the global like service locators in Cake is if you try and overwrite an existing key, it'll yell at you because you are trying to modify configuration when an object already exists and it has been used. So what's happening is the first test runs fine, the second test runs, and it blows up. And so what we're going to do instead is not do this. We're just going to log drop. You could probably get more elaborate with checking if the config does exist. So you could do like, if not log config container. So if that doesn't exist, then then we can set it up. Right, that's probably a more good way to do it. And then if we look, we should have a container log, unless I screwed up the slashes again. Did I screw up the slashes? No. Container log. File path is temp. That's container. It's not there. What's going on? So we never got a hi mom. Interesting. It should be in the temp folder. You're right. At least some people are paying attention. Not like me. Okay, so we got some high CakeFest in here. Yeah, you can put some exclamation marks on it to make sure it's doing the right thing. Yeah, at least I know you're all paying attention, right? Not everyone's asleep at the wheel. Yeah, so those are our ones with our exclamation marks. So that's how you can do configure some of the core objects from using the DI container. We can go back to the better version now that we know where the log file is. Put some question marks. Mess it up. We did mess it up. Parser. What? There's no parser. Bash parser. Yeah, so then we can set the config file, set the logging configuration up. You could do the same thing with caching if you wanted to read your cache, define your caching through the container. If you have like some sort of dynamic database that you're reading from, or some other more complicated configuration setup, you can do it that way. Yeah. Let's just go back to my notes. There we go. That's kind of logging and kind of database configuration. I think we have like 40 minutes left. Any questions or things that people are looking for that they didn't see so far around containers or testing? Make stuff ready for the next one. the next thing we're going to add is some browser automation. And browser automation allows us to do a few things. One, it lets us run test our application as a end user would use it. And so this means we're going to boot up a browser. We're going to connect to it through the Selenium WebDriver protocol, or through Chrome Driver, or one of those similar browser automation APIs. And then we're going to drive it around our app and click on stuff. And this will allow us to kind of simulate clicking on things and seeing what a user would do and pretending that we're a user. So this is really helpful if you have, like in Michael's tutorial where you're building a front-end application. Oftentimes you can test the front end in isolation with Jest, and you can test your API endpoints or your controller endpoints with PHP unit, but you can't test that they work together. So you can test like both halves of the bridge, but you don't know if the bridge exists in the middle. And so browser automation is a good way to do that. With that said, browser automation has some caveats. One, it is slow, slower than PHP unit tests. It can be very fragile if you do it wrong. And this will lead to a lot of flaky tests and like things breaking and timing out. And I can talk about like some of the strategies I found useful to make browser automation more durable. Yeah, so let's kind of jump in. Have folks used browser automation before? Yes, no? No, no one likes it. Everyone hates it. So we're going to use a library from Symfony called Symfony Panther, and Panther lets you do a few things. It lets you connect in the web server, the built-in PHP web server, and yeah, Cypress is another great one. Browser automation doesn't have to be fragile. It can be done. You can do it in a way that doesn't cause it to break. There are some tricks to it though. So we're going to add Symfony Panther, and we're going to install that. And Panther just kind of wraps up a whole bunch of different APIs together to make it so that it's a little bit easier. So it gives you kind of like a Panther client, and that Panther client allows you to interact with the DOM through Symfony's like the DOM crawler interfaces, I guess what they call it. Also gives you access to the browser kit interfaces. So it gives you access to a bunch of really good high-level interface, and it allows you to write test automation with it. Okay, so now we've got Panther installed, and kind of the setup for Panther is you have to set up your PHP unit, not the README file, this one. And we need this long piece of text. So we add the server extension, and the server extension will, when you start using Panther, will boot up a web server and then tear down the web server at the end of your test, which is super helpful. And we also need some extra configuration changes. So one of the things we need to do is have our web server connect to a database connection that is shared with our test cases. Because if we have our application attached to its standard database, the test database is not going to be the same. Like the test cases, you won't be able to insert data into one database and read it out of the other database. It's just not going to work. So you need both of them reading and writing to the same database. And so there's some additional indirection we can use to do this. And we're gonna go into how I've done it in the past. This may not be the best way. There may be better ways. Is the screen share frozen? No, I was just yakking. You should see a line moving around. We're going to go into config bootstrap. Can't type and move my hands at the same time. I wish, right? Oh, to be Goro. So what we're going to do is we're going to add support for an environment variable. And this environment variable just so happens to be one that that Panther can set when it boots up your web server. So we're going to find our app local. We're going to kind of augment app local to do a little bit more work for us. So we're going to read an environment variable called append. And if that environment variable exists, we're going to read that environment variable. We're going to read that application local config. So this is a way you can think of like, well, what if I wanted to have different configuration for staging or for production? I want to check everything in the repository for some reason. This is a way you could do that. You could set environment variables in each of your environments. It's another way to approach .env files. There's lots of ways to approach these. .env is another path. I just went with PHP files because I wanted to use fewer libraries. But .env is another way you could approach this. It supports, reading which env file to read from the environment. And so, yeah, different ways to approach things. And then we're going to grab a configuration file. What we're going to be doing is when we run our test for our acceptance test, we're going to tell the application that the environment is acceptance. So then we're going to need an acceptance environment file. So we're going to make one of those. Save that. We're not going to go there. We're going to go here. And we're going to just paste in a file. Let's go. We're going to turn debug to false so that we can test our application in a not test scenario. Oftentimes your users will be using the application in a non-test scenario. If you want to leave it in debug true, we can start it off with debug true and we can see what happens. We're going to set some salt values. We're going to read both the default and the test database out of the same environment config. This is the magic cheat that makes it all work, is that we're going to set an environment variable in PHP unit to be where the database lives. And then we're going to read that database configuration both in the web server and in the test cases so that they both point at the same place. If you have other shared data sources like caches or multiple databases or different data stores, you're going to need to do the same kind of thing so that both your tests and your application, its production mode, read from the test database. So you can trick your application into looking where you're putting the test data in. So this is the magic hack that holds it all together. It's not really a hack. It's just how it works. And we're just going to tell debug kit to be less annoying. Okay, so the next thing we need to do is tell PHP unit and to tell our test setup how we're going to talk to the database. So we go into our PHP unit and we're going to set another environment variable. We're going to set an environment variable here. And I'm going to set this as database test URL, and the value is going to be SQLite 4, I think. We're going to give it an acceptance database. So unfortunately, this is one of the tedious parts of using environment variables is you can't really do dynamic value substitution. So in CI, what I usually do is I have my PHP unit XML.dist, which is the default one. I usually commit it to the repository, comment it out. And then in my CI configuration, define all the environment variables that are going to work for that CI environment. So if I'm running tests on GitHub Actions, you initialize this to match the path of the database that will exist in GitHub Actions. If you're using Travis, same kind of thing, or Jenkins or whatever you're using for CI Circle, whatever. They all work with environment variables, so that you can set your environment variable up and then run your tests. I'm just going to use a local SQLite database. Okay, so the next step is to go into our tests bootstrap because we have more tricks to pull there. So we're going to go to test bootstrap. Bootstrap. And at the bottom, we're going to define some server environment variables to get Panther to know how to run a Cake application. So we're going to tell it two things. We're going to tell it, well, four things. we're going to tell it where the router script is for our Cake application. And the router script in a PHP local server is the kind of like the entry point into the application. Ours happens to be in webroot.index.php. We tell it the web server directory, which is webroot, and we tell it the acceptance, the Panther app-env. And so this Panther app-env, before Panther boots up your web server, gets swapped in as the environment variable of app-env. And we're also going to tell Panther that we're going to run it. We're going to run our browsers headless, and we're going to turn that to false for now. No headless. This is most backwards configuration. So no headless means you want a head, and so if you set no headless to true, you want a head, which means you get a browser window. If you set no headless to false, then you don't get a head, and you run a browser without a browser opening up on your screen. If you're running in CI, obviously you would set no headless to false. If you're debugging a test, you would set it to true because you want a browser to pop up so you can see what the browser is doing. Okay, next thing to do is add some directories to put our acceptance tests in. So we're going to add a directory, and we're going to put acceptance tests in here. I like to keep acceptance tests separate from the regular tests. The reason for that is usually you run them in different CI jobs. Because you don't want your acceptance tests to block up your unit tests, or your functional tests. So your functional tests can run in one CI job, and your acceptance tests can run in a second CI job. Or you can split your acceptance tests up across multiple CI jobs if you have a lot of acceptance tests. This is another way to make them a little bit more straightforward to run. Or you can make your acceptance tests optional, or maybe only run them, once in a while. There's a lot of strategies on like managing resources for your tests. And I'm just going to pull in some code I wrote before, and we can talk through it. So I'm just going to quote Vim to get the LSP to work. Okay, acceptance. Okay, so a couple things we're pulling in here. We're pulling in WebDriver. We're going to pull in the Panther test trait, and we're going to pull in the Panther client, which is how we're going to interact with Panther. We're also going to define some fixtures. With acceptance tests, you're going to need to define a little bit more fixtures, I find, because you're going to need the whole application kind of running. We'll have a client, we'll have a cookie jar, and after, because we're going to destroy the client so that we free up the memory so it doesn't leak, and we signal to Panther that we're done. And then we're going to build up a client. And this client we're going to build, I'm using Chrome WebDriver. On my other computer, I use Firefox. So if you have Gecko driver, or you can drive Chrome, I think you might also be able to drive Edge. I've never tried, but you definitely can drive Chrome. You'll need Chrome driver, and you'll need to match your Chrome and Chrome driver versions very closely, because they get really salty if they're not the same. Yeah, Firefox and Gecko drivers seem to allow a little bit more divergence in version numbers. And maybe you want to run all of your CI with Chrome and Firefox, I'm not sure. Anyways, we want to use cookie jar, and then we're going to make a 1200 by 1024 browser window. This can be really helpful if you want to run your CI suite both as a desktop browser or a laptop browser, and then you want to run another suite or another set of tests as a mobile browser. If you want to test mobile responsive, you can actually do that with Selenium, or with Panther and with WebDriver. And then we're going to return a client, and then I like to put a few like little helpers in across the application. So like here's the login function. A lot of times your application is going to need to log in to be able to click on stuff. So this is a good way to do it. And this also kind of gives a little bit of an intro onto like how we're going to use WebDriver and like how we're going to use Panther. So we're going to create a client, and then we can tell the client to go visit the login page. And then we're going to tell the client to wait for an element to be present. So a lot of times browser automation people will use sleep as a way to try and get to wait for the DOM to be ready. They'll be like, oh, I'll just sleep half a second. It should be ready by then. But then, you know, machine resource contention or other problems come up, and that second's actually, like, that half second becomes 1 or 1.5 seconds, and your tests fail, and then it becomes flaky and painful to work with. And so waiting for specific elements, I found, has been a much more durable and resilient way to operate. These have a timeout of 30 seconds. So they'll wait for the element, they'll just pull the DOM, querying for this selector, the CSS selector, which is input name of password. And they'll just pull the DOM continuously until that selector passes. Or if it doesn't pass within 30 seconds, then the test will abort and fail. And then we can submit forms. So in this scenario, we're gonna log in, fill in the login form. We haven't built a login form, but you know, if you were to build a login form, this is a way you could do it. It's kind of meant as an illustration of, like, you can build like a DSL into your test suites to make browser automation easier to manage. Yeah, and then you can also build in kind of helpers to click on elements. So the default click doesn't necessarily do all the mouse events you want. So if you have JavaScript or like React or Vue logic that depends on like mouse down and mouse up, you can actually trigger all of that. So you can use Panther to get the mouse, and you can move the mouse and like click on things. You can click down and then drag and let go. So you can build like drag and drop interfaces programmatically. And I've been able to write tests that do drag and drop, write tests that, you know, type keys. You can fill out forms, you can partially fill out autocompletes, and then while you're in the autocomplete, send keys to go down to move your cursor, like push the down arrow and, you know, scroll through an autocomplete list and press enter. So you can use browser automation to navigate all of that stuff. But what you will need is some better selectors, because building everything with CSS class names doesn't always work. There's this variety of technologies, like if you're using any of the CSS and JavaScript libraries, like Emotion or styled components, they'll generate class names and, you know, use those. So you don't even have class names. If you're using something like Tailwind, maybe there's too many elements with the right class name and you haven't gotten to the point where you've like refactored out components with class names that you want to click on. And then there could also become problems where, you know, you've written some automation using some style class names, and then someone renames a component and then breaks all the test automation. That's a bummer. And then your CSS refactor now requires like a whole bunch of like front-end refactoring. That's awful. So another way to approach it is to use a different attribute just for automation. And so if we go into our view template, just pull up my notes. So here we have like a typical post link. It doesn't have a specific class name on it, right? Like it's just a post link. So we could put a class name on it. Well, it does have a class name, but the class name is for the style, not for the kind of for the behavior. And so what we want to do is be able to have attributes that are just for behavior. And so what I've ended up using, just out of convention, because I'm familiar with how React does testing, they use a data test ID attribute, and then you can give it a name. And you can kind of build a convention across your team or across your test engineers or whoever's writing tests for your team, that these like data test ID values are used only for automation and only for test cases. And one of the nice things about using this data test attribute is you can also reuse it in your front-end tests. So if you're using Jest or Mocha or one of those test selectors, yeah, you could use the element ID value. Yeah, you could use ID as well. A lot of times what I found is if you have a repeated component, that you run into like duplicate IDs, but element ID is another good one that you could use. You just basically want something that's not attached to styling, that your team kind of agrees on is going to be used for, yeah, class name prefixes are another way to do it. I've seen it done as like, you know, your JS action delete, and this JS prefix kind of tells you that this is for automation, like don't muck around with it. But then you have it in the class name, and if someone's new to the project, they don't know like, oh, what are these JS prefixes for? Where are they in the style sheet? Oh, they're not used. I'll just delete them all, and then all the tests fail. So I found this like this data attribute allows you to have like that test. You could obviously have like class name prefixes as well, but this is one solution. There are a myriad of solutions. The point is to find one that works for your team that isn't using your style selectors and isn't using like crazy descendant tags. So you're not doing like div input, right? Like you don't want to be doing that. You want to have short selectors and be able to reference specific elements very easily. Whether you do it through prefix classes or anything like that, totally up to you. All right, so now we've kind of got some setup. Feel like the next thing we need to do is update our flash messages. So what we're going to do is we're going to use flash messages as a way to, one, check that the page is done and that the page is loaded and rendered. Because sometimes you can run into scenarios where you don't know if an action is complete. Or if you're building a client-side application, even more annoying is, has the page loaded? Which can be awful. Data test ID equals flash success. And so the loading one is an interesting one. Like if you're doing asynchronous requests, how do you know when the page is done? What I've gotten into the convention of is if you have a div that's doing like a loading spinner, div class name, class is loading, right? And then there's like a sweet SVG in here, right? What I have gotten into the practice of doing is giving all the elements that are spinners as data test ID equals loading, or you can call it like loading indicator or whatever, some sort of name that you and your team agree on. This is one of the advantages that a data test ID has, like a data attribute has over an element ID, is if you have multiple spinners on the page and you want to wait for all of those spinners to go away, you can just every little spinner, or like you have big ones and little ones. Sometimes you have like little progress bars or like, pulsating boxes that tell you that an element isn't quite ready or hasn't, finished loading its data. You can just blast data test ID on all of them and give them all the same data attribute. And then you can have your browser automation just wait for none of those things to be in the DOM. So like wait for all of the loading indicators to go away. And then your test, like if you're loading a page and then asynchronously loading more data, once all the loading spinners are done, then you can start interacting with the page. And so that helps a lot with like resiliency around a test. Like you could even build in a retry mechanism, like, pull for 30 seconds, raise a retry error, and have, PHP rerun that test again. So that's a strategy that's worked out well for me, is all the things that are loading, give them the same data test ID attribute, and then you can see it in Jira. Like if you use Jira has like that sketch UI, and that has like, I think there's like a sheen that goes across in Jira, or like Asana does it as well. There's like pulsating boxes everywhere. It's obnoxious. Okay, so our flash messages are looking good, ready to be browser automated. And then we can do we're going to make a new browser automation. Let's call it like edit user. Right. Do declare script. Here. Equipments. Factory. And I find I like writing acceptance tests around specific scenarios versus like, here are all the tests for the user's controller. I find out it's easier for me to process and like understand an acceptance test suite if it's written as like based on the workflow that's being done. There are also like a myriad of other tools that you can do to write acceptance tests. Stuff like bhat, a lot of like the Gherkin family of tools where you write like, as a user, I want to, and you write like a user story with like all those like if and when. I found those to be useful. What I've found is there's that bhat DSL adds another layer of indirection and complexity to the test cases. And I find that, processing through that Gherkin format and then processing, like in my brain, processing, like reading the Gherkin and then translating, like, what does this if when statement, what does that mean in PHP code? Like, what is the browser actually doing? That's another layer that I have to like read through and like pattern match and like read the regex for all the Gherkin steps. So I found that to be harder to work with than keeping PHP code simple, because I'm not very smart sometimes. I've also, one of the promises with like Gherkin and bhat is like, oh, you can get your product manager to write it. I've never been able to do that. They laugh, or they're like, you want me to do what? So then you end up writing it all, and then you just made more complexity for yourself, which is a bummer. Just made more work for yourself. All right, so now we've made a user, and we can get our client for, right? And then we can tell our client, this is a browser client, by the way. We're going to tell our client to go get the users, and then we're going to go to edit. We're going to do user ID, because we're using a dynamic fixture, so we don't actually know what the user's ID is. But it turns out it doesn't matter. And then we're going to do client wait for. Now we have to wait for the page to load, so we should go back and add a data test ID. I don't know, main. Let's do that. And we'll go into our layout. Splat a div on here. Data test. Right, we're going to pull it out. Along those lines. All right, so then we wait for the page to load, and then we're going to submit the form. So we're going to just fill out the form. So Panther gives you a few things that kind of help. So if we look at that user's edit, this is the form we're going to fill out. So we have a form, and then down here at the bottom we have the text, the button we want to click on, right? So that text matches, and then we have to fill out, what kind of fields do we need to fill out? And it looks like we need to regenerate our views, because our views are wrong. We're going to run into that same problem we keep running into. Yes. All of them. Okay. View. Who earns? Action. That was nice, but still. Okay, so we're going to submit the form, and then we're going to wait for the page to finish loading. Wait for. We're going to wait for data test ID equals flash success. So this is us waiting for the page to reload, and then waiting for the flash message to show up. And then what we're going to do is we're going to wait for the page to load, and then we'll know that the database change that we wanted to have done has taken effect. So we're going to just fetch our user. So we're going to do this fetch table. We're going to get the users table. We're going to get user ID. Yeah, so we're going to get a user record, right? And then we're going to do this, assert updated email username. We want to make sure it is updated at .com. Okay, so that's our first, baby's first browser automation test. I'm just going to throw a sleep in here so I have enough time to grab the browser window and put it into the desktop that is being shared that you can see. Here we go. Here goes nothing. User, yeah, that one. Let's see if we get a browser window. Oh, here it comes. Oh, groups associated is not defined. That's good. That's good. We're doing things. Things are happening. It's good. We have the browser talking to the test suite. And what's probably happening is our users controller is telling, yeah, it's got a contain there. That's no good. None of that. And get rid of that one. And the browser waited for 30 seconds and then decided it had enough. Let's clean that up. Clean that one up. Clean that up. That looks pretty good. Let's try again. Oh, it's too slow. Okay, we need more sleeps. We're going to sleep for 5 seconds. And I move a browser window in 5 seconds. Here we go. Oh, I don't know if you saw it. I cannot get it to. Okay, let's put another sleep in here. So we're going to wait for the browser window. So this is because, you know, I'm slow. And this is, we're going to make sure that the flash message displays. And this is the only time I would recommend you use a sleep in browser automation, is when you're manually debugging and you want to like visually inspect things. It should never be part of your like actual test workflow. You should instead be using wait fors and all of that kind of stuff. There's a question from Casey regarding testing with PHP unit. We have an idea of the code coverage that was generated. If we enable something like xdebug with Panther, is there a way to see what hasn't been covered? No, you cannot collect coverage from a browser automation, which is one of the bad things about browser automation. So, and the reason for that is you have PHP unit running in this process. And what PHP unit is actually, what Panther is doing is you start, we create that client, and then that client spawns a web server process. And that web server process is very similar to like when you run bin cake server, you get that server process. And so you have the PHP unit, you have a browser automation. I don't have a third hand, but imagine my face is the browser. So those are the three processes kind of involved. And so the browser is looking at the web server, and PHP unit's over here. So you can only really capture code coverage from PHP unit. You cannot capture code coverage from the other process. Yeah, you also can't, like, if you print in that other process, you can't see it. So we can test that out right now. So if we were like, if we go in our users controller, so browser automation does have some challenges around like what you can do and what you can't do. So if we go in here and we do debug, hi CakeFest, it's not going to show because I have debug off. But you know, whatever. Okay, let's just turn a var dump on, right? And let's see if I can get the browser window moved over quickly enough. So there's our browser window. It's updated. At no point in time was that var dump ever printed out. So you can't actually see in the var dump. So how do you work with that? And the way I've been working, the other thing you can't do is you can't use breakpoints in the web server. That won't work either. Yeah, so it's not without challenges. But I think it's worth a minimal amount, it's some amount of investment. I would not recommend you run all of your test cases through browser automation. It's going to be expensive and slow, and just probably not worth the effort. But what you can use browser automation for is like your critical path workflows, your important things, the things you don't want to break, that you want to have that extra assurance of like driving your browser around on. Think of your sign up page. Think of like your pay, how you get paid. I like getting paid, so like maybe we make our payment page have browser automation so that we can test that out. Again, you run into like dependency problems where if you're integrating with Stripe, you can't mock out Stripe because it's in a web server versus the other side. But focus on your high value flows. Focus on like where if it breaks, you're gonna get interrupted, or there's gonna be a whatever your company or team calls an incident, a production incident or production outage, right? Think of like those areas and think about investing there first with browser automation. And once you get some success and some wins, start extending it into other places. That's how I would approach it. I wouldn't try and like cover all your validation scenarios with browser automation. You're wasting your time. As we saw earlier, it's way faster to do all your model permutation testing just with the table, and you can do all your API enumerations just with controller tests, right? And so use browser automation to focus on like just your happy paths, maybe 1 or 2 failure scenarios. You can test all of that kind of stuff. And one area I found browser automation has been really helpful for is capturing snapshots. So taking screenshots of the browser and then comparing those against known images. So you have to invest in some additional tooling. There are services like Percy that do this. And so you can have a browser, part of your browser automation suite be taking screenshots and then comparing those screenshots with the last known screenshot. And how this has been valuable for me is in my day work. I don't do this on hobby projects, obviously. In day work is a lot of times someone can restyle a component that is used in multiple pages, but they don't always know about all the other places it's involved in, and nor do they make the time to go back and check all of those UI pieces. So if you have a very high bar that your team is trying to reach with design and the way the UX looks, you can use browser automation to like double check, like do a visual sanity check against your application. And so I found that has been a pretty valuable way to use browser automation, in addition to like clicking on things. All right, so that's kind of how you can use Panther. There are more complex scenarios, obviously, and over time you're going to end up with kind of a big mess of this. And what you might want to do is like, how do I refactor some of my like flows, right? Like I have drop downs. I have a long, complicated form where I have to like interact with multiple drop downs and then fill out all those values and then submit the form at the end. And a good way to approach that is through another layer, but not quite as heavy as Gherkin. So you can create another directory. We'll call it page objects. And this is borrowing from a pattern that is used quite a bit in the Selenium community. And so you build a class that kind of, let's just go through it. Users edit page, right this, it's in the wrong spot. We're going to move it into page objects. Okay, and again, this is just going to be another like basic PHP class. And we're just going to call it like class user edit page. And for our constructor, we're going to take a Panther client. I've forgotten what the type info that is. For that. Right. we can do stuff like we could have methods on this. Like we could have like public function complete form, like submit form, right? And we'll take like an array of fields. And if we go back to our acceptance test case, just refactor this real quick. We have kind of this stuff. So we want to like, edit, submit form. Submit, or like complete form. The names are hard, but you can imagine this is a more complex scenario, right? So we're gonna take this, and we're gonna go down here, and we're gonna do that. Okay, and then we're just gonna do, maybe we have functions, maybe there's some inheritance and we have some shared page objects where we build even more common stuff, so you can like wait for page, right? We can do this. We wait for the page, and then we're going to do this like this, and then we're going to do except from single time. So then you're starting to get into more like a DSL, right? Like we're starting to have, then our test becomes, maybe we do page is equal to the new user edit page, right? We pass in the client, and then we do page. What if we have like a visit method? That'd be kind of neat. And we don't actually know. Or we go view. Right, so we can do, and then we can do view, we can do, even wait for our page there. We can do wait for the page, and then we can do page complete form, and then kind of paste all that in. And then our test becomes a lot terse, right? Like page becomes a little bit more easy to understand. The test becomes a little bit more easy to understand. We're opening a user's page. We're going to use the user's page kind of helper, and then we're going to view the page. Acceptance. Payback. So we're going to make that user's edit page. We're going to, view the user. We're going to complete the form, and then once we're done, we're going to fetch the user out of the database and then make sure it got updated. Okay. We change this to fields. Okay. We'll put that sleep back in. Actually watch it run. Ooh. Wait for flash success. Interesting. Ah, yeah, typos. more time. There we go. So then you can get to, a much terser, a little bit more elegant test scenario. And then if you need to update a selector, like maybe these selectors do change for some, unknown reason or unforeseen reason, then you can, you can accommodate that. You can also document everything. So when you go into your test cases, you know exactly what the test is going to be doing. Okay. You can get like IDE completion for all your tests. So it turns into a really straightforward kind of system to work. Someone changes the submit button, you can just change it to like go, 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 go. And you only have to change it to one place and fix multiple tests at the same time. Yeah, you could make more users for sure. And you could look at the index test. You could go and delete a bunch of them, make sure that the users were actually deleted, all that kind of stuff. So yeah, that's a lot of what you can do with browser automation. And then as for like, how does that get set up in, like maybe you're using GitHub Actions for CI. I don't know, I can show you how I've set it up for one of my side projects for Docket, which Michael referenced earlier. So it's running with MySQL, run checkout, we install PHP, we install and build the JavaScript. So that's building, running Vite, and then we run PHP unit. And I've kind of shimmed this around because I wanted to only run one test at a time. But yeah, that's pretty much all there is to it. It wasn't really hard to set up in GitHub Actions. It wasn't complicated. Gecko driver's already installed, Chrome driver's already installed, Chrome and Firefox are also already installed in a lot of CI services. So it's pretty straightforward to get going. See that thing I was gonna show. One other neat thing you can do with tests. So a lot of times people use caching a lot in their tests, and then they run into, the cache persists between tests, or you have to like flush the cache. Like what if you didn't have to flush the cache between tests or between test runs? What if you could just have it kind of flush out at all? Or like, what if you wanted to turn the cache off entirely? How could we do that? And if we go back to like that app local config, we can look at how our caching is set up. Cache, nope, in app. Okay, so we can use these cache default URLs to kind of inject a different cacher. Because whatever's the URL going to replace what are the other, it's kind of a neat feature of how our global service locators work. If we go in here, we can go here, we can do env, just get the names of them. Name is cache default. Okay, and then we can set the value to be, this is a cache adapter that was released a few versions back, maybe in 4.1 or 4.2. And so what we can do is just replace the cache with an array. So now it's not going to talk to Redis, it's not going to talk to memcache, it's not going to talk to the file system, and it's not going to leave anything behind between test runs. So if you run PHP unit and then run PHP unit again, there's not going to be any cache left over. There's not going to be any need to run like cache clear or anything like that with a CLI command, or even like clear the cache, at the end of the test. Another one you can use is the null cache adapter, which is a pretty neat cache adapter. Make sure we have a null cache. Yeah, the null engine is a great one. So we're looking at the cake source, which I recommend you do if you ever want to know how something works. Just crack open the source code. And so the null cache adapter does great stuff. It's very fast, very scalable, and very consistent because it always does nothing. So if you write to it, it doesn't actually do anything. It's like, cool story. I'm gonna throw that away. That's neat. So yeah, this is can be a big performance win in your cache. If you want to test like what happens if the cache is broken, you can use the null cache. Or if you want to just run without caching, or if you don't want any like caching artifacts left over, it does have its use. I'm a big fan of the array cache in tests because then you get a little bit of the cache. One downside with the null cache is if you use it for the model cache, yeah, it's like null for caching. It's like using MongoDB. I'm joking. MongoDB is actually a pretty good database now. So if you use it for the cake core or the cake model cache, bad things will happen to you. So I would never suggest you do this. Don't ever do this. Instead, use it as an array. Rolling aside, Mongo is actually a really good database now. For certain workloads, it's great. So don't do this. Don't put this one as a null, because what'll happen is all your schema reflection queries will fail. Well, they won't fail. They just won't do anything. So the next time you kind of get the model schema from the cache, it's not there. So you do another database query. So this will actually make your test suite significantly slower. Don't do this. Instead, do this. And what this does not leave cache files in. It does not cause any file system overhead. There's no passing stuff around. It all just turns it into memory. So if you have enough memory to soak up all the cache stuff, do this. It'll help. And yeah, you can do the same thing like here. Yeah, don't use null cache in production. Don't listen to Casey. This is bad news bears. Like you can, but it's not going to be. You're going to have a bad time. Yeah, so that's one way you can do cache. Another good piece of PHP unit tech is having different test suites. So if we were to run PHP unit right now, what's going to happen is it's going to run all the functional tests, and then it's going to run all of the acceptance tests at the same time. I don't know why tests are failing, but we didn't break anything. So what we can do instead is change this to acceptance. So we define 2 test suites. And this can be really good if you have like, you want different CI jobs, and you don't want to have to like reconfigure which tests run in which CI jobs. Using PHP unit test suites is a great way to do that. And then you can also set like the default test suite to be app, right? And then when you run PHP unit by default, it'll just run some of your tests versus all of your tests. And if you want to run the other, just the acceptance tests, you can run just acceptance tests. Just waiting for Chrome. So yeah, you can run just the acceptance. So yeah, so that's another like PHP unit technique that I've found pretty helpful is yeah, splitting up your tests into oh god, cache to Salem fraud. Like you can, I don't know if it's a good idea. That kind of gets me to the end of the prepared content I had put together. If people have questions, happy to answer those now, or if there's stuff people want to see about testing that they didn't get to see or that I didn't cover. Yeah, I'm happy to spend a little bit of time. I think I have like 10 minutes left. Just gonna check with Amanda.
Yeah, we have 10 minutes. So if anyone has
10 minutes?
Questions, yeah. Well, 13. Yeah.
Oh, we love precision.
Yeah, I'm gonna be careful now.
Time zones. Time zones, time zones. Poor Australia, man. Those new time zones they have are wacky. Feel bad for them. All right. Well, I'll be around on Slack for probably the rest of the afternoon in Eastern time, which is another like 2 hours. So if there's stuff you want to ask, yeah, I'll be around. You can just hang out and you can look at my basement for another 10 minutes. That's fine too.
Well, if nobody has any questions,
several people are typing in Slack. Oh.
Yeah, I see everybody's.
No, it's nothing. I think people are done. It's been a long day.
It's pretty late some places. So
Yes.
I know somebody messaged me and said it's like 2 a.m. I'm like, that's dedication, hanging out with us until 2 in the morning.
Yeah. No, it's late in Europe. It's like another 6 to 8 hours from where I am. So
it's hard to find, like, when we were picking the times for everybody to kind of like something that works for everybody. So
there isn't. The stupid Earth is a ball.
yeah, why? Like time zones. Yeah. But thank you guys. Thank you everybody for joining us. We've got a full day of talks and coming tomorrow. You can check out the schedule, of course, online, cakefest.org. If you are using us, hashtag CakeFest, hashtag cakephp. We hope to see you tomorrow. Do not forget, especially since we have Mark here with us right now, do not forget your cake. And hopefully you're going to be with us tomorrow, right, Mark, to cut it? Okay. We might have a special like addition to the cake cutting ceremony tomorrow. So
I don't know how I'm gonna I'll just maybe open a cupcake or something.
Yeah, everybody.
That's what I was thinking.
Yeah, so I've already got mine. If everybody will go to your local bakery, get a small cake, get a small cupcake, and we'll all like. Cut.
If you want, you can get a big cake too. If you want, just eat the whole thing.
Here because it's tempting, but yeah, so we are technically all eating cake together like we normally would. So.